So here I've already written out the areas underneath the curve. So if you want to find the integral from 0 to 12 here, all they're asking is, what's the area beneath the curve from 0 to 12? So you see we have a 2 pi up here, 2 pi plus 2 plus 2 plus 1, which is a 5, and then you subtract the area on the bottom here, which totals out to be 4. And that just gives you 2 pi plus 1. This is a rule we're about to learn. So you see how in the second problem here, it's from 12 to 0. It's kind of backwards. You should always start with the lower number on the bottom. You can rewrite that as a negative sign in front, but then just reverse the order. See, negative integral from 0 to 12 f of x dx. So we already had our answer from part 1, 2 pi plus 1, so we have a negative sign in front of all that. Negative parentheses 2 pi plus 1, which is negative 2 pi minus 1. So we're going to learn a lot of properties of definite integrals today. I just showed you one right there. So equivalent limits. If you have the integral from a number to the same number, well, the integral is just 0. Reversal of limits. That's what we did just now. If you switch the order of the bounds of the integral, so instead of b to a, it's a to b, you have to put a negative sign in front of it. It should always be from lowest number to the higher number. Multiply by constant. If you have integral from a to b and there's a constant in front of the function, you can move that constant to the outside of the integral. You'll see some of these are very similar to derivatives. If you have an integral from a to c and then c to b, that's the same as just one integral from a to b, f of x dx. So that's like saying the integral from 0 to 12, we can write that as the integral from 0 to 6 plus the integral from 6 to 12. That's the same as integral from 0 to 12. So if you have the integral from a to b of parentheses f of x plus g of x, you can separate those two integrals. So that's the same as saying the integral from a to b f of x dx plus the integral of a to b g of x dx. It's like the sum different, it's the same as the sum and difference rules with derivatives. Same thing with subtraction. A to b f of x dx. Now we're just subtracting integral from a to b g of x dx. Let's go to this example right here, question 3. So the integral is from 7 to 6 f of x dx. The first thing we want to do is rewrite it so it's a lower number and the top number. So it's negative integral 6 to 7 f of x dx. So what's the integral from 6 to 7? From 6 to 7, that's just a rectangle or two squares, so it's 2. And there's a negative in the front of it, so it's negative 2. So question 4, integral from 12 to 8, 3 f of x dx. There's two things we can do. We can reverse the order of the limits at the negative sign in front and also put the constant 3 on the outside. So it's equal to negative 3 integral from 8 to 12 f of x dx. So from 8 to 12, this is a triangle area 1. This is another larger triangle area 3. So this area underneath the curve is a 4. And this is below the curves, below the x-axis, so it's negative 4. So it's a negative 3 times a negative 4, which is equal to a positive 12. So given that the integral from negative 2 to 1 of f of x dx is equal to 4, integral 1 to 5 f of x dx is negative 3, and integral from negative 2 to 1 g of x d of x is 8, find the following. This is the integral from 5 to 1 f of x dx. Again, we can rewrite that as negative, switch the order, 1 to 5 f of x dx. And that is just equal to, well, negative 3, which is a positive 3. from negative 2 to 5 f of x dx. So we can take that as the integral from negative 2 to 1 f of x d of x plus the integral from 1 to 5. And that is 4 plus negative 3, which gives you a 1. Circle that answer there. So this is the integral from negative 2 to 1, parentheses f of x plus 2g of x. Again, we can split it up like this. Integral from negative 2 to 1 of f of x dx plus 2 integral negative 2 to 1 g of x dx. Again, this is the sum and difference rule, and also moving the constant to the outside the integral. So that's equal to, well, this right here, they tell us is 4, plus 2 times the integral from negative 2 to 1 of g of x dx is 8. So it's 8 right here. So it's 4 plus 16, which is equal to 20. Let's see, the integral from 0 to 1 f of x dx. Unfortunately, there's no way we can determine that. It cannot be determined. Because no matter what combinations we try, there's nothing that gets us just the interval from 0 to 1. So E is the integral from 1 to negative 2, 3 f of x dx. So we can reverse the order of the bounds and have a negative in front and bring the 3 on the outside. So it's negative 3 integral from negative 2 to 1 f of x dx. And we have and this is 4. So it's negative 3 times 4, which is negative 12. F, well, this is the integral from the same number to the same number, so we automatically know that's 0. Question 6 and 7, you can skip both of these. I'm not going to worry about you guys graphing these. So we're going into this one now. What is the difference between the absolute value of the integral and the integral of the absolute value? This is a key difference right here. So if the absolute value is on the outside, all you do is, well, write the absolute value on the outside, and then this is a negative pi over 2 plus pi over 2 plus 2. So that's just, well, negative pi over 2 cancels out. That's 2. And the absolute value of 2, well, that's just 2. However, if the absolute value is on the inside, you can think about this area being positives. Typically, this is negative, but if you absolute value this on the inside, this turns into a positive area. So this becomes a positive pi over 2 plus pi over 2 plus 2. Pi over 2 plus pi over 2 is pi plus 2. So keep in mind, if the absolute value is on the outside, you find the area underneath the curve as normal. Whatever answer you get, just make it positive if it isn't already. If the absolute value is inside the integral, you want to, even if any area region is below the x-axis, you just make that positive and then add them all up. So question 10, 11. I'm not going to care about you guys graphing this, but I'm going to want you guys to know how to do integrals, definite integrals on the calculator. So to go to integral, you click on Math 9. Oops, Math 9 is Fn integral. The bounds from 2 to 3. And then it's the square root of x minus 1 dx. So this answer here is 1.219. 1.219. I want you to pause it and try this integral on the calculator on your own right now. If you input it correctly into the calculator, you should have got an answer of -4. you can go ahead and start the practice, and you can skip the questions that require graphing, but you can do them on the calculator.